Hello, welcome back to Flip. So now we are on the second portion for macromolecules. Now we are describing polyethene formation and example of addition polymerization and some uses of polyethene and how to deduce a structure from a polymer product given a monomer and vice versa. Okay, so this is the last part we'll be talking about. So let's begin with the formation of polyethene. So in our previous video, we mentioned that polyethene, okay, it's a addition, okay, polymerization. So that means what? That means that if I have a white brick, okay, remember we used Lego examples in the previous video. So if I use a white brick and maybe a brown brick, okay, it will exactly give me a white and brown brick. Okay, it's just like that. Okay, there's nothing special about it. Okay, there's no additional product form or anything. Okay, so this is addition polymerization. So in this case, we have ethene as the monomer. So ethene in this case is the Lego brick. Okay, one single Lego brick is ethene. So how does this work is that I have 3 ethene molecules lined up here, as you can see. So I want to combine them. Okay, I have to basically draw a bond between them. Am I right? So draw a bond between them, but I cannot do that right like this. Okay, because like I said, there should only be 4 bonds around carbon. In this case, if I draw this, there's only 5 bonds. There are 5 bonds now. So this cannot work. So what happens is that, okay, instead, this carbon double bond, okay, has to break. So all these pink bonds, okay, all these pink bonds have to break, okay, because actually, by breaking this, you can then form this. Okay, let me show you and you tell me if it makes sense. Okay, so I keep only one bond between the 2 C's. Okay, let's just draw one first. So from this to this pink bond now becomes 2 electrons on the other side. Okay, because if you remember, one bond is made up of 2 electrons side by side. So by breaking up this pink bond, I have returned them into these 2 electrons and then placing, okay, these 2 electrons back to this side. Okay, of course electrons don't move like that, okay, but this is just an illustration sake. So this bond now goes to the other side. Okay, and that's why you end up with 2 electrons on the other side, keeping one bond between the carbons. Okay, so hopefully that's clear. Let me draw for this too. So it's the same here now, with a C-CH, okay, and with 2 more bonds, 2 more electrons. Another one, C-CH, 2 electrons. Okay, so as we can see here, one of the bonds in CC double bond breaks. This one, the pink one. So bonds can form between neighboring C molecules. Okay, and now we form the bond basically. Okay, so now from here, okay, what I have to do really is just to join them up. Am I right? Just like that. Okay, and that is all actually. It's not that difficult. Okay, so C, single bond C now. H with a dash. Okay, so I can just do this. Okay, this is the lazy man method. Okay, I can just draw the C bonds first, then I fill in the H's. Okay, and this is how we get the polymer. Okay, this is how we get the macromolecule. So from this guy, you can see individually, okay, I can now form a long chain. Okay, this is addition polymerization because there's nothing lost. It's just 1 plus 1 plus 1 gives you 3, for example. Okay, so then we can see that this is the repeating unit. Okay, you can see that this is the repeating unit. It's quite simple because you have been given the monomer. Am I right? So this is the repeating unit. So you know that the answer, if I would ask you what's the repeating unit, you can give me the answer as, sorry, this is the repeating unit. But if I were to ask you for the monomer, okay, it's quite simple. You can just tell me, oh, hey, it's just up there, isn't it? This is the monomer, right? Yes, you're right. This is the monomer. This is the monomer. But if you were not given this monomer, how do you actually deduce? Am I right? So it's quite simple. This one, you have to just look for what is repeating here. In this case, this whole chunk is being repeated again and again. Okay, and that's why you can know that this is the repeating unit, but you know that you cannot just write this out as the monomer, because on its own it cannot form this bond. It has to start from a double bond here, and that's why this is the monomer. So this is the difference between repeating unit and monomer. Okay, repeating unit exists in a long chain, but monomer exists on its own. Okay, so you have to do some conversion here by knowing that these two bonds have to come back in between them to know the monomer. Okay, so, but I'll give you a further example on this later. Let me just move on to the users first. Okay, and the naming of them. So to name polymers, okay, is really just poly. Okay, the name poly stands for many, am I right? Okay, plus the name of alkene. So for example, in the case of the just now example, okay, this is my ethene, right? So if I have many of it, okay, it forms a long chain, am I right? Okay, this is, okay, many ethenes. Okay, you'll eventually form a polyethene. Okay, and that's why this is how to name them. Okay, poly plus the name of alkene. In this case, I use ethene, polyethene. So you can do with other alkenes as well. Users for polyethene is really just two. Okay, please memorize. It's plastic bag and clingfilm. The good thing about them is that because they are used as such, because they are light, waterproof, and cheap. But the bad thing is that they do not biodegrade very well. So which means they use up a lot of space to be buried. Okay, and they fill up the landfills very quickly. So it's a bad thing also. Okay, so back to the how to identify monomers. Am I right? So this is another one. This is PVC. This is not in your syllabus per se, okay, as in you don't have to know how it's derived, okay, everything. But this is this could be a question to test you on your knowledge for identifying monomers. So, like I said, this is the chain being given. You just have to look for the repeating patterns. So I have a H, okay, so all this H, okay, there's nothing to infer from here. There's nothing to infer from a C as well. But you can see that from this HCl, 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 you know that it's repeating every HCl. Do you agree? Okay, every HCl it repeats, every HCl it repeats. So this must be the repeating unit. Okay, and this must be the repeating unit. Same for this. Okay, and you can know that it will carry on all the way here, all the way here. Okay, so from this, I know this is my repeating unit. Okay, it's obvious. But I don't know what's the monomer, because as with the previous example, the monomer is given to me, right, for polyethene, but in PVC case it's not. So how do I know? I can really just, okay, just look at this green bond here. Okay, I return this electron back to him, back to the CC, and now what do you see? Okay, let me use back the same color so it's clearer. I use blue. Okay, blue. The single bond is also blue. Okay, H is also blue. But I'll use green color to illustrate this bond here. So if I break this bond, okay, obviously it's bonded to another repeating unit, right? You can imagine. So I return this electron back to him. It actually forms this bond, a green bond. Okay, and now it's back to a ethene. Okay, and this I know, okay, is the repeating unit monomer. Okay, sorry, this shouldn't be a H. This should be a Cl. Okay, and this is the monomer I'm looking for. Okay, and this is how you, from a long chain, you go into the repeating unit and you go into the monomer. Okay, so with more practice, it should be no problem at all. Okay, for going with these 3 steps. Okay, it should be quite simple. You just have to see the pattern. Okay, in this case it's HCl, but of course this thing can change. Okay, it may be even up to 3 or 4. Okay, you never know. Okay, so just practice more and you'll be fine.